the market itself should come all the way out to here at about 3,000 terabitu's. So if people just implemented the stuff engineers can think about, you'd save a fabulous amount of energy. And then this thing takes off for the sky. And that's because of how the list was made. What did they do? They sat around and thought about things that would work. They didn't sit around thinking about things that wouldn't work. Then they took the things they thought worked, and they did a little bit of research to figure out how much they would cost and whether or not they would really work. When they ran out of ideas, then they started pricing stuff that was wildly expensive, and that's why it turns up. Now, if you took another 20 people in another 2 years and did this project, what would happen? You'd think of more stuff. You probably wouldn't think of a lot more stuff that was really cheap, but you would flatten this curve out a lot. So the fact that this curve heads for the sky somewhere is an artifact of how much effort the engineers put into thinking about it, more than what the truth might be out here. The interesting point is that anytime you do these, you'll find a lot of things down here near zero. I've never seen a set of engineers do a conservation supply curve and not conclude there was a lot of energy to be saved for near free. And that opens up a question. I mean, we're economists, right? If something was free or near free, presumably it would just be done. So why isn't it being done? I'll leave that as a question. You want some answers? Got answers? Why is it that a bunch of engineers, in this case Skip and Friends energy engineers, can sit down and, in a couple of months draw up a curve like this and have evaluated a couple of hundred technologies that people really could use and come to the conclusion that there's lots of money and energy sitting on the table, and yet it doesn't happen? I want your answers for why. Nobody really knows the answer, so your answers are as good as anyone's. No answers? How could this be? How could there be that much energy sitting around and nobody went to claim it for near free? Yeah, that could be one answer. All right, so what does it do to take you to know something is there? Yeah, but is just telling you enough? What? Say what? Yeah, was that easy? Okay, so think of things you actually buy that are advertised. You buy anything that's advertised? Yes? How much advertising does it take to get you to buy it? Is it just like, hey, look, you really ought to be buying this. Buy. Does that do it? Does that get your attention? Does it get your attention? No. What do they have to do? They have to show you, someone said lifestyle. They have to show you that if only you had a Watson, your lifestyle would be great. All the problems in your life would obviously disappear overnight, et cetera. They have to lie through their teeth repeatedly, and then maybe you'll try it. But I had an experience with the technology good. I had a computer, it was a long time ago, and the thing was relative, by today's standards, it was ridiculously slow. The thing was about this big, this tall. We had to run special power into the room to get it to run. And I assure you that the CPU ran hugely slower, like at least 1,000 times slower than one of these things. Maybe more than 1,000 times slower. Maybe it's now 1,000,000 times slower. Yeah? And it worked. And people had made new stuff. It was actually Sun that had made some new stuff. And their stuff was supposed to be much, much faster. Like hundreds of times faster. It was just hard to believe it. I actually made them bring one to us. This guy shows up, one of their salesmen shows up with a hand cart and a computer. I mean, it was this big sort of thing, half the size of what I had before. And he says, where do you want it? I said, stick it over there. He stuck it over there. We plugged it in and we tried it. And then it was like, yeah, wow, it really does work. It's not the usual height. But that's what it took to convince us. I mean, reading articles by people, they all lie. Why would we want to believe them? And then another company said, the original company, DEC, said, well, we have one like that too. Maybe you want to buy ours. And we said the same thing. Fine, lend us one. They said, nah, but we'll give you a line into one and let you be the only one to do it. We don't have to physically bring it. And so we discovered that theirs didn't work as fast as the other guys, plus there were some problems with it, and we didn't buy theirs. But that's what you have to do with a piece of industrial equipment. Well, you got a refinery. You want to go experimenting with a refinery? Maybe not. Refinery engineers make their living, by the way, looking at a refinery and eventually coming to the conclusion that that part needs to be replaced with a bigger one or a different one. And it's a long process before they're really willing to go yank it out, and they got to turn things off to do it and put something new in. So doing it all the time, but it's not trivial to them. So what happens when an energy guru, Skip Leitner, says, hey, you guys in the aluminum industry, I know your business better than you do. You ought to be doing more advanced recycling. What would be your natural response if you were in business? Thanks a lot, Skip. Have another beer, right? That'd be your natural response. And that's the way it is. You can wander around the university. We have a university. Wander around the university and find examples of energy just being thrown away. My favorite one was there's a noise-making machine next to my office. It runs 24 hours, 7 days a week, and makes white noise. It was originally designed to be a water fountain, but it actually doesn't cool the water. All it does is run continuously and throw out heat into the atmosphere. And I wanted them to turn it off, because I don't like the white noise. So the first thing I did is I unplugged it, but they sent somebody to replug it. And so we had plugging and unplugging for a while. And then I got really annoyed at them because I really don't like the noise. And I had our assistant dean, or actually our management director, call them up and tell them to replace it or at least to unplug it. Then somebody came by and cut the plug off, tucked the thing in, it doesn't run anymore. So now you get room temperature water with no white noise. But how many people are willing to take an hour out of their day to stop people from running water fountains that have no freon in them? Well, not many. So that's why people like Skip can think of these things. It's because there's another side to it too. People really are that stupid. And I assure you, if you wander around the university and you just ask yourself, what are these people doing that makes no sense? You will find an endless number of things, just absolutely endless. And that will be true anywhere you go. I absolutely promise you that'll be true anywhere you go. So I have sympathy both sides. On one side, you're asking me to take my plant that's running profitably and try some new thing that's not easy to try. And I'm reluctant to mess with things that are working. And on the other side, you can wander around and find huge amounts of energy inefficiency in nearly any building or facility. So I have sympathy both sides to that. And do I quite believe this? It's on the board? Nah. But is there a long ways to go? Yes. So maybe the truth is this thing isn't out at 3,000. Maybe the truth is it's only out to 1,000 or 1,200 or something. But the system doesn't force them to find it. And it's not so easy to make actual change happen. It's much easier to draw the diagram. But that's a conservation supply curve, and should you go into the environment business, these things will show up on your desk. And that's the way engineers express their beliefs about what in a system could be changed to make the environment better. And I think we don't start another set of slides. So, goodbye.